Welcome back to the Exchange Server Client Access Service course. In this course, we're going to talk about how do you publish client access services to the internet. And to do this, we are going to go through the security requirements of publishing your Exchange servers to the internet and how do you manage those settings. So it's pretty important nowadays to have Exchange servers available on the internet because people roam, they fly around the world, they access through their mobile devices. So making client access services available through the internet is part of messaging infrastructure. You no longer just publish Exchange servers internally, you now make it available externally as well. So when we implement your Exchange servers and make it available to the internet, we have a couple of things that you need to go through. So the first thing is a checklist. So they always say that when you do anything, it's always good to plan that before you actually do that. The 80-20 rule. Plan more and do less so that you know exactly what you're going to do.
Unfortunately, that's not always the case in the real world, but it would be a better world if it were true.
Yes. So and that's why you're watching this course is you want to go and learn something before you actually do that. And I want to remind you that you should look at the edX course as well and make sure that you go through all the lab exercises there that we have available. So make sure you have your checklist of everything that you need to do before you implement your Exchange environment.
Right, and that checklist is going to include things like namespace planning, DNS namespace planning, the type of certificates you're going to choose for client connectivity, planning your external URLs. There's a number of things that you would have on that deployment checklist and then give your attention to.
Okay. Then once you have your certificates, and we recommend that you use trusted certificates. So a trusted certificate is something that is trusted by the internet. It's not just trusted by you because you can sign your own certificates. You want somebody to sign your certificates that you trust because the devices that you're going to connect will not trust any certificate. And so there's certain organizations out there that sign certificates for that's their business. And when they sign certificates, you know that they've gone through the due diligence to make sure that you own that domain, you are the organization of that domain, and so they issue the certificate.
Certificate authorities is what they're called, right?
To you once they've gone through all those checks. If you use your own system, you can set up your own certificate authority inside of your domain infrastructure, a PKI, public key infrastructure. Then only you will trust that certificate, and devices that is part of your Active Directory will trust that certificate. A device like a phone is not part of Active Directory, so that device is not going to trust.
Or a remote client like Outlook Anywhere or MAPI HTTP. Yep. Those clients, unless they're domain connected, aren't going to have the root certificate just by default or through a GPO or anything like that.
So those things will allow you to, if you have a trusted external certificate authority, public certificate authority, then you will automatically trust it.
That's the best way because all operating systems come with the root certificates for all the most not even just the most popular, but even the most unpopular certificate authorities.
Yeah, and you don't need to worry about issues that will happen on that device that it's not able to connect to the Exchange server.
Right, and this probably ties into namespace planning too. So when you do request a certificate, you have to be mindful of the type of DNS names that you need to be stamped on that certificate.
Yep.
So there's different namespace models out there. For a single site deployment, I guess the easiest namespace model is just a single namespace, what's called the centralized data center model. And in these days, really the only two DNS names that you need to be concerned with is usually like the host name that you're using to connect to mail. So like mail.adatum.com and autodiscover.adatum.com, in its simplest forms.
And you could buy a certificate that's got both of those names in the certificate, so you don't need a certificate for the one name and another certificate for the other name.
No, the best practice is to do exactly that.
Yes.
A SAN certificate.
Yes, that's a subject alternative name,
Right.
SAN certificate. So it contains different names in that same certificate. Because the way a device trusts a certificate, it actually evaluates three things. The first thing that it evaluates is the name that I connected to, is that one of the names on the certificate? That's the first thing that it evaluates. If it's not one of the names that I connected to, then it's going to give you a warning and say, this name mismatch, this server is trying to be imposer or something like that. The next thing that it evaluates is, do I trust this certificate? Because this certificate needs to be signed by a certificate authority that I know about, and that is the root certificate. That is part of this process, that is already part of a lot of devices, and so it's going to check that as well. And then the final thing that it checks is the date value of the certificate. The certificate has
it expired?
Yes.
Or is it still valid?
So it's got a set time that it's issued to you, and once that time has expired, then you don't know what happened to that certificate. So that's the three things it's going to check to make sure that the certificate is valid. And so the name that's in that certificate is really important, because that allows you to connect to the Exchange server.
And another alternative to a SAN certificate would be a wildcard certificate, where, again, if you're using whether it's 2 or 3 different host names to connect to, say you're using Mail to connect to Outlook on the web, mail.adatum.com, autodiscover.adatum.com for those clients that support Autodiscover. But let's say you have POP clients that need to connect using pop.adatum.com. Well, you can get a SAN certificate, but those are expensive, more expensive than, say, buying just, say, a wildcard certificate, which would be stamped with a DNS name of *.adatum.com, where the asterisk is a variable that maps to any host name that you try connecting with.
Okay, so there's options there as well. Wildcard, if you have lots of names, then maybe a wildcard is more preferable. Some clients I've heard do not support wildcard certificates.
This is true.
So you need to check if your clients, all your mobile devices, do support wildcard certificates. And this has become less of an issue now than it used to be. 5 years ago, there was still a bunch of mobile clients out there in the wild that didn't support wildcard certificates. But nowadays, most of them do support wildcard certificates. Then you also have to set up client authentication, client access authentication. So different protocols like ActiveSync will use basic authentication, because that's wrapped inside of SSL, so it is protected. But Outlook on the web would use form-based authentication. And so you have to set up how you're going to allow authentication in your environment as well.
Actually, a lot of that's done for you these days. If you look at the right out of the box, the most common used authentication methods are already set on those virtual directories, and the only time really that you really need to give that much thought is if you're, say, in a mixed environment with older versions of Exchange or multiple sites where you have like maybe previous versions of Exchange installed, where you need to perhaps disable forms-based authentication on one of the servers for a particular reason, and the only server that needs to have forms-based authentication enabled is, say, the one that's internet facing.
Okay, well, so I think with that, let's look at the certificate wizard that's in Exchange Server 2016. When you and this allows you to set up that certificate that is required to host this system securely. And this was previously in Exchange 2010, you had to run commandlets to create certificates, but now it's this nice certificate wizard that makes it really easy to host or to generate new certificates. So yeah, I have my Exchange server, and in here you'll see I can go to servers, and you'll see it lists my servers, I can go into certificates, and for my certificates, I can create new certificates and make it available to my servers. So I click on this plus sign and then say, oh, I'm going to create a new certificate that I want to send to a certificate authority. Alternatively, I can create a new self-signed certificate. Now, self-signed certificates works well if you just use and connect to your Exchange servers, and the Exchange servers connect to themselves. Self-signed certificates are fine for that, but the moment a client comes into play, and that's always because clients want to connect to Exchange servers, you need to have a certificate that is trusted, because self-signed certificates are not trusted. So, but there's some cases where you may want to do a self-signed certificate. So most of the time you're going to use a certificate that you want to send to a certificate authority. So you give this a name. So I'm going to give this a name that the certificate will be called. And then at this point, I can say, oh, I want to create a wildcard certificate. If I create a wildcard certificate, I can tick this box and then just specify the domain that this wildcard certificate will be created for. Or if I don't want to specify a wildcard certificate, I need to go to the next step where I have to specify all the different names. And then you specify where it needs to store this request file. So the request file is the file that will be generated by the certificate process, and it will then save that file on the server. So I'm going to store this on this server. And here I'm going to specify the name. So it gives me a bunch of names built in, like the Outlook web app name. So maybe I want to use mail.adatum.com. Maybe I have an internal name that I'm going to publish to users, the server name, or I can use the same name as well. What's the offline address book download point, the Exchange web services, and so on. So you can check all of these and change them to a value. So say pop, then you can edit this to say, okay, for pop, I'm going to use the name pop at adatum.com. If I click next, it will summarize all the names that I need. So here it saw that I want mail.adatum.com and the server name auto-discover, the pop name that I just added. And at this stage, I can also add any other name that I thought, wasn't in the previous list, and I just want this to be part of this list as well. I can also specify what will be the primary name. So if I click on this and I click on this checkbox, then that will become the primary name, the subject name of the certificate. So usually that will be the nice name.
The common name.
The common name.
Yeah.
And then I click next, and then you have to give the extra information that will be part of the sign request. So what's the organization name? What's the department? Where is the certificate? And a very controversial subject is London. What state or province is London? Nobody knows.
They haven't figured that out yet, huh?
Yeah, so London is not in a state or province. So those of you that's watching this in the UK, if I offend you by typing in England, I'm very sorry, but I need to type in something. And then you finally specify the country as well. And so in this case, I'm going to select the United Kingdom. And then click next, and then you specify where this request file will be saved. So if I just specify my local server cert mail.rec. Then this, now it's going to go and generate this new file certificate. What's important to know is that this server actually stores the private key on the server. If you lose this server, then you're going to lose the private key that's associated with the certificate. When you send the certificate to a certificate authority, you only send the public part of that certificate to that server. You don't send the private key to that, because you don't want that private key to be compromised in any way. So you only send the public part of that certificate, and then the public certificate authority will sign that certificate part, the public part, and then you get a certificate file associated with that, and you come back here and you complete the process. Once it's signed, you import that certificate, and it will then be a proper signed SSL certificate with a private key that stayed on the server. Once that private key is signed, you can then export the certificate and make it available to all the other servers. So that's a certificate wizard. Really easy. It takes you through the whole process to quickly set up a new certificate on your server. So once you've set up your certificate wizard and you've deployed that to all your servers, you also have to configure ports and firewalls to make sure that your servers are accessible from the internet. A lot of people forget about that, so they need to open up port 443 from the internet to your intranet, the mailbox servers,
for HTTPS traffic.
For HTTPS, and that will allow clients to connect from the internet to the mailbox servers on HTTPS. Some organizations have a requirement to connect to the perimeter network first, so then you would set up some sort of application layer firewall that terminates the connection from the internet in your perimeter network first, and then it reestablishes that connection.
After it inspects the packet.
After it inspects the packet, and then it would then connect to the mailbox server as well. So application layer firewalls, or a reverse proxy. Some people call it a reverse proxy. So that's another option. You need to also make your client access servers for internet purposes as well as internet purposes part of a load balancer. So
mailbox servers with client access services.
Yes. So those have to be load balanced, and so your load balancer will make sure that if something happens to one server, that the connections will be failed over to another server. Some people want to use Windows load balancing. That is not a good idea to use Windows load balancing.
Plus you can't when you have a DAG configured.
So if you have a database availability group, you can't use both of them, failover clustering and Windows network load balancing on the same server. So that's not a good idea. So you would use a hardware load balancer. And for the hardware load balancer, we recommend a layer 7 hardware load balancer in Exchange Server 2016, because you want to make sure that your hardware load balancer is aware of the connections that is available. So it's got a health probe that connects to the client access services on that mailbox server to make sure that those services are available and healthy. So it checks through the health probes to see if those servers are available. This layer 4 load balancer doesn't have the ability, because it's just at that point
transport
TCP IP. So it's TCP, and it just checks if the port is open. If the port is open, it doesn't know anything about the service running on that port, so it might be down. So for that reason, a layer 7 load balancer is important. But in Affinity,
it's no longer important.
It's not important, because the client access service will get you to the right point at the end of the day. So you can connect to any of the client access servers in that pool, and through proxy, it will get to the right mailbox server.
Although we should probably mention, because we talked about Office Online Server and how it's used with the data collaboration feature in Outlook on the web, the recommendation there is to use a layer 7 load balancer with Affinity.
Yeah, because the Office Online Server doesn't have this concept of the proxy and so on. So it's not able to recover if the affinity is not there. So you need to have a consistent affinity settings. So that wraps up our module on Exchange and how do you publish your client access service to the internet. I hope you guys found that useful, and stay tuned for our next module on client access services.